Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Far away, beyond every star you've ever seen, there are places where time itself seems to forget how to move. At the center of nearly every galaxy, those swirling cities of stars, rests a black hole. But not all black holes are hungry or loud. Some are quiet. Some are asleep. These are the sleeping giants of the cosmos, the ancient hearts of galaxies that no longer roar, but rest in stillness so deep, it feels like the universe is holding its breath. Imagine a spiral of stars, millions, billions of them, turning slowly in the dark. At the center of that spiral is a place with no light, no sound, and no movement. This is where a dormant black hole lives. It isn't swallowing stars or tearing things apart. It simply waits. Like an old volcano that once erupted with fire but now wears a blanket of snow, it sleeps in silence. Scientists call these black holes dormant because they are not actively pulling in matter. They have eaten all that was near, and now, with nothing to feed on, they have become invisible, almost forgotten. Yet even in rest, a black hole is not nothing. Its gravity still whispers across space. The stars near it still dance in slow orbits, caught in its unseen grip. Gas clouds drift gently around it, moving like silk underwater, drawn not by touch but by the deep, invisible pull of mass. These giants may be silent, but they still shape the galaxy around them. They are the heavy anchors holding the galaxy together, the sleeping weight at the center of a cosmic wheel. No light can escape a black hole, and that is part of what makes them so mysterious. When they are active, we can see the bright chaos of matter falling in. But when they are asleep, there is no light, no glow, nothing to see. Only the motion of stars and gas gives away their presence. Astronomers use this movement to find them. They study how things move, how they drift, how they swirl, and from this, they draw the outline of the invisible. Long ago, before it fell asleep, a dormant black hole was likely a powerful force. It may have been born from a massive star that collapsed at the end of its life. Or it may have grown over billions of years, swallowing stars and dust, growing larger and heavier, until finally it had nothing left to eat. It is this history, this ancient hunger, that lies curled up inside the quiet. We think of space as empty, but galaxies are full of life. Stars are born and die, planets spin in silence, and at the center of it all the sleeping giant rests. Some scientists believe that even the quietest black holes could wake again. All it would take is for something to fall close, maybe a passing cloud of gas or a wandering star. The black hole would stir, stretch its gravity, and begin to feed once more. But until then, it remains like a shadow in the shape of a scream that never came. These sleeping black holes remind us that the universe holds not just fire and force, but also pause, also hush, also waiting. They are reminders that even the most powerful things can rest, and in their rest they shape the world around them in ways we can barely understand. The quiet ones at the heart of galaxies do not shout, but they do not disappear. They stay. They hold. They remain deep and dark and full of gravity. Let's drift deeper into the quiet. Imagine standing on a faraway planet that orbits close to the heart of a galaxy. Above you, the sky would not just sparkle, it would shimmer with rivers of stars. But if you looked toward the center, you would see nothing. No glow, no flicker, just a blank space where the stars seem to spiral inward and disappear. That space is where the dormant black hole sleeps. Not dead, not gone, just hidden in a cloak of darkness thick enough to bend the path of light itself. The more we learn about black holes, the more we realize how much they shape everything around them, especially when they sleep. In their silence, they leave room for galaxies to form, for stars to grow undisturbed. While an active black hole can shine brighter than an entire galaxy as it feeds, a sleeping one whispers instead of roars. This silence lets planets orbit in peace and clouds of gas cool enough to give birth to stars. In this way, dormancy is not emptiness, it is permission. It is space for creation to unfold. Scientists often study black holes by looking at what surrounds them. They look at how stars move in loops that aren't quite circles. They watch how gas clouds thin and stretch as they near the hidden edge. Like wind around a mountain we can't see, the flow gives shape to the invisible. We may never see the black hole directly, but we see its fingerprint on everything nearby. The way light curves, the way time slows, the way space itself seems to lean inward. These are signs of the sleeping giant's breath. Dormant black holes are not rare. In fact, they might be the most common kind. Every large galaxy seems to have one. Some are enormous, weighing more than millions or even billions of suns. Others are smaller, more like heavy seeds than giants. Some formed early in the universe's youth and have not stirred in eons. Others may have just gone quiet recently. What they share is patience, a kind of timeless waiting that stretches across light years and centuries. There's something haunting about this quiet. Black holes are born from violence, supernovae, collisions, collapses, yet when they sleep they give the impression of peace. Perhaps this is why we call them dormant, as if they could wake with a yawn or a twitch. But their sleep is not like ours, it is deeper. It is written into the fabric of spacetime itself. Nothing about a black hole can be touched, not even its edge. Once something crosses its invisible line, the event horizon, it cannot come back. Not light, not sound, not time. Still, the mystery draws us closer. Telescopes like the Event Horizon Telescope try to glimpse the edge of these shadows. Data from X-ray space observatories tell us when a black hole has stirred just for a moment to snack on a passing cloud. But even when there is nothing to see, we feel the pull. Scientists dream of finding the very first black holes, tiny ones from the start of time. They believe that some of those ancient ones might still be out there, curled up in deep space, waiting. Silent but not forgotten. Some theories even wonder if every black hole holds more than just gravity. Could they be doors to other places, other times? These ideas are still just dreams, but even in their sleeping form, black holes seem to reach beyond science. They invite poetry. They stretch the edges of our understanding. Like a forgotten story written in the sky, they wait to be read, not in ink or light, but in the way galaxies spin and stars breathe. There's something beautiful in the way a dormant black hole holds still. It does not chase. It does not speak. It waits. And in that waiting, it becomes something more than just mass and darkness. It becomes a question, a shape that bends time, a silence that sings, not with sound, but with the quiet rhythm of gravity and memory. Perhaps one day our own galaxy's black hole will wake again. Or perhaps it will stay asleep, letting stars bloom and planets form in its gentle shadow. Either way, it reminds us that even in stillness there is power. Even in the deepest quiet, the universe is listening. And maybe, if we listen too, we'll hear it breathing beneath the stars. Now imagine the journey of a photon, a tiny piece of light, drifting near the center of a galaxy. It has traveled across space for thousands of years, slipping between stars, weaving through clouds of dust. But as it nears the dormant black hole, it begins to feel the pull. Not a tug like gravity on Earth, but a slow, deep stretching of space itself. The path of the photon bends, curves, and spirals, caught in the embrace of something it cannot see. And then at the very edge it escapes, lucky, forever changed. Its path will tell scientists a quiet story. The sleeping giant is still there, still shaping the space around it, even without a sound. Some black holes will never wake again. They have eaten all nearby stars. Their galaxies have grown old and the cosmic pantry has been emptied. In this eternal quiet, the black hole becomes a monument to time itself. It exists untouched for billions of years. Its gravity does not fade. Its presence never softens. Yet it remains still. This is not death. This is rest at the scale of galaxies. It is the long pause after a cosmic symphony, when the last note echoes into silence and space holds its breath. Other black holes do wake. Sometimes a wandering star gets too close, pulled from its path by a thread of gravity. It stretches like dough pulled too thin and disappears into the horizon. For a brief moment, the black hole flares with energy, light bursting from the chaos at its edges. But then the moment passes. The meal is over. The black hole returns to sleep, darker and heavier than before. This cycle may repeat every million years or more, like the slow breath of something vast and ancient. It teaches us patience. It teaches us scale. What is most surprising is how necessary these sleeping giants are. Without them, galaxies would not form in the same way. Their mass keeps the stars in orbit. Their silence allows for balance. They do not lead, but they anchor. They do not shine, but they steady. In a way, black holes are the quiet gardeners of galaxies, not by touch, but by gravity, not by light, but by shape. They sculpt the cosmos by simply being still. Children often ask what's inside a black hole. The truth is we don't know, we can guess. We can build equations, but inside that sleeping core is something science cannot yet reach. It may be a point smaller than we can imagine. It may be something we cannot yet name. But even without answers, the black hole teaches us how to wonder. It invites us to ask. It invites us to keep looking up. Dormant black holes also remind us of the future. One day, long after stars stop forming and galaxies stop glowing, black holes may be all that remain. They will drift through a dark, cold universe, alone but unbroken. Their sleep will continue, deep and silent, as time stretches on without a sky full of stars. In that far future, the last light may not be a star, but the soft whisper of something falling into a black hole, a final flicker before everything goes quiet. Still, here and now, we are lucky. We live in a universe alive with light and movement. And even though the black holes at the heart of galaxies are asleep, we can still feel their presence. Through telescopes, through motion, through mathematics, we come to know the giants in their slumber. And in doing so, we learn more about the nature of space, of time, of ourselves. The quiet ones at the heart of galaxies do not tell their story with light. They speak through silence, through orbit, through gravity. They teach us that not all power must be loud, that not all change needs a flash. Sometimes the greatest force is stillness. Sometimes the deepest truth is hidden in the pause. And sometimes the heart of a galaxy beats not with fire but with the hush of a giant dreaming in the dark. Some stars end their lives with a bang. They explode into brilliant supernovae, scattering their insides across the galaxy, lighting up the night sky with a final burst of energy. But not every star chooses such a loud goodbye. Some fade gently, collapsing inward not with sound but with gravity. These are the ones that fall asleep forever. These are the stars that leave behind black holes, dark, quiet places where time and space twist together like threads in a forgotten dream. Imagine a star much larger than our sun. For millions of years it has burned hot and bright, a giant furnace fusing hydrogen into helium and helium into heavier elements. It pushes outward with its light, its heat, its pressure, always fighting against the inward pull of its own gravity. But one day the fuel runs out. The light fades. The balance breaks. Gravity wins, and the star begins to collapse. At first the collapse is fast, faster than anything we can feel on Earth. Layers of gas fall inward. The core tightens. Temperatures soar beyond imagining. In some cases the collapse triggers an explosion, a supernova that blows away the outer shell of the star. But in the heart a black hole is born. It is not a place. It is not an object. It is a boundary, an edge beyond which nothing can return. Not light, not time, not even memory. From the outside there is little to see. The black hole itself is invisible. But if the star left behind a swirl of gas or a nearby companion, that material might spiral inward, glowing as it falls. This is how we sometimes catch a glimpse, not of the black hole, but of what it leaves behind, what it still touches. A faint light, a moving star, a whisper of X-rays in the dark, traces of a star that once burned, now folded into silence. Some stars skip the explosion. If they are heavy enough, they collapse straight into a black hole, swallowing their own voice before it can even scream. These silent collapses may be more common than we once thought. Telescopes that watch the sky for supernovae sometimes notice something stranger, a star that simply vanishes. No burst, no flare, just gone, as if it slipped beneath the surface of space, falling through a crack in the universe. What remains is a black hole, dormant and quiet. It no longer shines, it does not glow, but its mass, its pull, its presence remains. Like a stone dropped into still water, the ripples continue long after the stone is gone. Stars near the black hole shift their paths. Light bends around it. time slows beside it. And deep within, where physics falters and questions multiply, the memory of the star is held tight, folded into curves and silence. When stars fall asleep forever, they do not die in the way we understand death. They become something else. They trade heat for gravity, flame for silence. They become a doorway, not one we can walk through, but one we can wonder about. What lies beyond the event horizon is still a mystery. It is a region where our laws of science dissolve, where time and space may fold together in ways we cannot yet explain. These black holes born from sleeping stars are scattered across the galaxy like quiet reminders. They are not rare. They hide in plain sight, tucked among the stars, each one a tiny shadow where a sun once lived. Some move alone through the dark. Others orbit other stars, tugging gently on their companions, a ghostly waltz between light and gravity. In these pairs, we sometimes see the black hole feeding, nibbling at the edge of its partner, flaring briefly before returning to sleep. But even the ones that never stir still matter. They are part of the galaxy's quiet structure, the hidden bones of space. Without them, the balance of stars and motion would shift. Without them, we would miss the full story of how stars live and how they rest. The quiet end of a star's life is not an end at all. It is a transformation, a folding in, a deep breath taken by the universe itself. So when you look up at the night sky, remember, not every star still burns. Some are sleeping. Some have folded into the dark, and in their silence they continue to shape the cosmos. Like soft notes at the end of a lullaby, they whisper of what came before and what still lies beyond the reach of light. Let us drift deeper into the stillness left behind when a star collapses. The birth of a black hole is not just an end, it is a quiet beginning. From the outside, the star that once gave light and warmth is gone, but something new begins to shape the space it once filled. The black hole does not announce its presence. It does not flicker or pulse. It simply is, a deep knot in the fabric of the universe, a place where gravity gathers so tightly that even light cannot stretch free. Inside galaxies like our own Milky Way, these stellar mass black holes rest in silence, tucked between clouds of gas and fields of starlight. Most are alone, having formed from stars that had no companion. They drift through the galaxy like invisible seeds, but some live in pairs, orbiting with a visible star. In these cosmic duets, the black hole remains unseen, but its partner betrays its secret. The star moves in strange loops, tugged by a force that has no face. It speeds up and slows down in rhythm with something we cannot see. These motions are the soft footprints of a star that fell asleep forever. Sometimes the black hole begins to feed. If the living star gets too close, its outer layers are drawn inward. The gas forms a swirling disk, glowing as it heats up, spiraling faster as it nears the event horizon. This sudden brightness is how we often find these otherwise invisible objects. It's not the black hole itself that shines, but the falling gas, compressed, heated, shouting its last light before disappearing. These short-lived meals are rare, but when they happen, they offer a brief window into the black hole's world. Yet most of the time, the black hole remains dormant. Like a candle that has burned out, it leaves behind no glow, only gravity. But even in this quiet, it holds the story of its star. The mass it carries is a memory, the weight of all that the star once was. In this way, the black hole is both tomb and monument. Not cold, not cruel, just quiet, just waiting. The idea that a star can fold into darkness challenges our understanding. It reminds us that space is not just empty, and time is not just a line. In the curved space around a black hole, time slows. Clocks near its edge would tick more slowly than those far away. If you could hover just outside the event horizon, a minute for you might be an hour, a day, or more for someone far from the black hole. This stretching of time is not a theory. It is a measured fact, part of the strange beauty of general relativity. And it tells us that even in sleep, a black hole reshapes the rhythm of the universe. When we observe the stars near black holes, we see another layer of their influence. Some stars orbit these invisible giants with incredible speed, tracing tight ellipses in the dark. Others wobble slightly, their paths perturbed by something they cannot touch. These stellar motions give us clues about the number and location of black holes in our galaxy. Astronomers believe there may be tens of millions of stellar mass black holes, most of them invisible, most of them resting. But not all black holes stay asleep. Sometimes galaxies collide, stars are flung from their orbits, clouds of gas are compressed and stirred. In the chaos, a dormant black hole may awaken, drawing in matter like breath. Its disk may blaze, its surroundings may flare with radiation. Yet once the meal is gone, it returns to rest, heavier, quieter than before. This pattern, quiet, flare, sleep, is part of the life of the cosmos, repeating across billions of years. And yet, for all we've learned, mysteries remain. What happens inside the event horizon? What lies at the singularity, the point at the center where all the mass is crushed into a single place? We have math, but not full answers. We know how things behave near a black hole, but not within it. These questions are not failures. They are invitations. Black holes, especially the ones left behind by sleeping stars, remind us that science is not just answers, it is also wonder. It is the soft light of curiosity shining into the dark. So we listen to the silence. We watch the stars dance. We trace the paths they follow and the shadows they avoid. In these shapes, we see the outlines of black holes. In their quiet, we hear the soft memory of stars that once lived, once burned, and now dream in the deep. Now let us follow the memory of one particular star, one that lived long ago in a quiet corner of the galaxy. It was larger than our sun, and for millions of years it burned with steady light, sending warmth across empty space. Around it, planets may have formed, comets may have passed, and moons may have spun in silent rhythm. But like all things in the universe, the star had a limit. Its fuel began to run low. The balance between pressure and gravity weakened. And slowly, its own weight pulled it inward. In those last moments, the star did not scream. It folded. Layers collapsed. The center squeezed tighter and tighter until something changed. No light could escape. No signal could reach beyond. Where there was once a shining sun, there was now an absence so complete it reshaped space itself. And just like that, a black hole was born, not with noise, but with a whisper too deep to hear. If we could drift close to where this black hole rests today, we would find almost nothing. No glow, no heat. Just an empty stretch of space where stars curve slightly in their orbits. A place where light seems to bend for no reason. A patch of sky that hides something vast and invisible. Around it, the galaxy continues. Stars are born, gas clouds drift, and cosmic dust spirals like slow smoke. But here, at the center of stillness, the black hole waits. What remains of that star is not a body, not a surface, but a boundary, the event horizon, a line that cannot be crossed in reverse. Once something passes through, it is gone from our view. We do not know if it is destroyed or simply stored, held tight in a place we cannot yet reach. The star's mass remains, and so does its pull, but its light, its face, its memory is hidden. And yet, through this transformation, the black hole continues to shape the world around it. In the future, another star may drift too close. Its edges may be pulled away, stretched and folded into long streams of glowing gas. The black hole may flare, just for a moment, before returning to sleep. Or perhaps it will remain undisturbed for billions of years, a monument of gravity resting in silence. Whether active or dormant, the black hole does not age in the way stars do. It simply persists. There is something comforting in this quiet endurance. Stars are fragile, beautiful, but brief. They burn through their lives quickly, racing toward their ends. Black holes, though born from these burning lives, seem to last forever. They do not shine, but they do not fade. They do not move quickly, but they do not drift away. They stay. They wait. They hold space open in the universe for questions we have not yet learned to ask. In time, our own sun will reach the end of its life. It is not massive enough to become a black hole. Instead, it will expand into a red giant, shedding its outer layers and leaving behind a white dwarf, a soft ember of what it once was. But somewhere in other parts of the galaxy, heavier stars will still be collapsing. Black holes will still be forming. The process will continue, slow and quiet, like the turning of a page in a book written across the stars. And maybe, long after we are gone, someone else will look up and wonder. They will see the same shapes, the same curves in the motion of stars, the same silent centers. They will build telescopes, launch satellites, and write poems about the darkness between the lights. They will try to understand what happens when stars fall asleep forever, and they, too, will listen to the quiet for answers. So the next time you see a star in the night sky, remember, not all stars still shine. Some have finished their journey and become something else, something invisible but still powerful. Their silence is not absence. It is presence of another kind, a kind that speaks through gravity, through motion, through space itself. The black holes left behind by sleeping stars are not empty. They are full of memory, of weight, of wonder. They are the universe's way of holding on to what once was and making space for what will be. There is a place where light forgets how to escape, where time no longer flows forward, where every step toward the center becomes slower, heavier, until movement itself loses meaning. This place is called the event horizon. It is not a wall, it is not a surface. It is a boundary, soft and invisible, surrounding every black hole, and once something crosses it, it cannot return. Not because it is destroyed, but because the very shape of space has changed. The rules have shifted, and the outside can no longer see what lies within. Imagine a traveler floating near a black hole just outside the event horizon. To them, the stars still shine, their watch ticks, their breath moves in and out, but as they drift closer, something changes. From a distance, they appear to slow down. Their motion stretches like warm honey. Light from their ship grows redder, dimmer, softer, until it fades altogether. To the outside world, they never quite vanish. They just freeze, locked in place, right at the edge. But to the traveler, time continues. They fall inward, pulled across the event horizon without pain, without explosion, only silence. This silence is deeper than any hush we know. Inside the event horizon, space curves so sharply that all paths lead inward. There is no direction that leads out. Every line of time, every thread of motion bends toward the center. Not even light, which usually moves faster than anything else, can outrun this pull. It is as though space itself has turned inward, folding around the black hole like petals around a seed, gently closing with no way back. What lies beyond the event horizon is one of the greatest mysteries in all of physics. We call it a singularity, a point where gravity becomes infinite, where our equations break down, where the known laws of the universe fall silent. But a singularity is not something we can see or measure. It is the end of what we know, the edge of our understanding. Some scientists believe it may not even exist as we imagine it. It may be a signal that we need new ideas, a new theory to describe what happens when matter is squeezed into perfect stillness. From the outside, the black hole looks simple. It can be described with just a few things: its mass, its spin, and its charge. These three numbers tell us everything about how the black hole behaves, but they do not tell us what's inside. They do not reveal the history of the star that formed it, or the planets that once circled it, or the light that fell in. All of that information, all of that story, is hidden beyond the horizon. Perhaps it is gone. Or perhaps it waits, quiet and folded, in a form we do not yet understand. This is the breathless silence of the event horizon, a line that separates not just space but knowledge. We know how gravity works outside. We can measure how time slows, how orbits bend, how light escapes. But inside, we are blind. Our instruments cannot follow. Our math turns to whispers. And so we imagine, we theorize, we wonder. Some theories suggest that the information swallowed by a black hole is not lost, that it may be stored somehow on the surface of the event horizon itself, like a hologram, that the boundary is not just a point of no return, but a kind of cosmic memory, an imprint of everything that ever fell in. This idea is called the holographic principle, and it is still being explored. If true, it could change how we think about space, time, and the very fabric of reality. For now, the event horizon remains a soft edge of mystery. We have seen its outline, thanks to incredible telescopes that captured the shadow of a black hole in a distant galaxy. We have heard the ripples of its birth, when two black holes collided and sent waves through spacetime itself. But we have never crossed it. We have never touched it. We only know it is there, waiting, holding a silence that reshapes everything around it. This silence is not empty. It is full of gravity, full of questions, full of presence. It does not shout. It does not glow, but it marks the place where the known becomes unknown, where the universe folds in on itself and begins a new story, written in a language we have not yet learned to read. Let us imagine drifting closer to the edge of a black hole, where gravity is no longer just a pull, it is a reshaping of everything we know. As you float toward the event horizon, the world behind you seems to grow far away. Light stretches, bends, fades. Time, which once moved in steady rhythm, begins to slow down. To someone watching from a safe distance, your fall appears frozen like a photograph held in place. But from your own view, everything continues. You fall. You pass through. And then, you vanish into a region where our understanding ends. Outside the event horizon, everything has a path. A beam of light can travel from a star to your eyes. A planet can orbit a sun. But inside, all directions curve inward. There is no out, no escape. Not because something pushes you, but because space itself flows inward like a river. You don't fall into the black hole as much as you are carried. Like a leaf drifting toward a drain, you are swept along by the shape of space. This strange bending of space and time is not just a guess. It comes from Einstein's theory of general relativity, which tells us that mass tells space how to curve, and space tells matter how to move. A black hole is mass so dense, so concentrated, that it doesn't just curve space, it folds it. Near the event horizon, this folding becomes extreme. If you tried to shine a flashlight outward, the beam would curve back toward you. If you dropped a ball, it would fall not straight down, but inward through space itself. Every path ends at the center. Every story folds inward. Inside this invisible border, there are no safe paths, no way to hover, no way to pause. Everything falls. Even time itself seems to slip. If you carried a clock across the event horizon, it would keep ticking for you. But to the outside world, it would seem to stop. The closer you get to the center, the more time slows. And at the very middle, time may cease altogether. We don't know. No signal can leave. No message can be sent back. The laws of physics break down. We enter a realm of silence. Yet this silence is not the end of curiosity, it is the beginning. Scientists are now asking deeper questions. What happens to the information that falls in? If a black hole swallows a book, a planet, a person, what happens to the patterns, the shapes, the data that made those things what they were? Is that information lost forever? Or is it preserved in some hidden form? This is called the black hole information paradox. It is a puzzle that has inspired new ideas, new math, new ways of thinking about the universe. One possible answer comes from quantum physics, which says that information cannot be destroyed. It may change form, it may be scrambled, but it is never truly gone. If that's true, then black holes cannot simply erase what they swallow. The information must go somewhere. Some scientists believe it may be stored on the event horizon itself, etched into the surface like code on a computer chip. Others think it may leak out slowly through a process called Hawking radiation. Stephen Hawking proposed that black holes are not completely black. They emit tiny amounts of heat over time, caused by quantum effects near the event horizon. This means that black holes can, very slowly, evaporate. Over unimaginable stretches of time, they may shrink, fade, and finally vanish. But if that happens, where does the information go? If the black hole disappears and all it held is gone, is the story lost? No one knows for sure, but the search for answers has led to some of the most exciting ideas in science. String theory, loop quantum gravity, the holographic principle, all are attempts to understand the silence inside the event horizon. Some of these theories suggest that black holes may be bridges to other places, other universes. Others suggest that space and time themselves are made from tiny threads, woven together in patterns we cannot yet see. The black hole, once thought of as an end, is now seen as a key, a door to deeper understanding. But even as we chase these ideas, we are limited. We cannot build a probe that crosses the event horizon and sends back data. We cannot watch what happens inside. We can only guess, based on what we see from the outside. We watch stars disappear. We measure the motions of light. We listen for the ripples of colliding black holes. And from these clues, we draw the outlines of a place where silence is the only answer. Still, there is wonder in this silence. The event horizon is not a wall, it is a veil, a line drawn in space that invites us to look closer, to ask harder questions. It is the place where what we know meets what we don't, where light ends and imagination begins. And though we cannot cross it, we can stand near it, in awe of what lies beyond. Far from the black hole, the galaxy continues its slow, silent dance. Stars burn and fade, planets spin in their orbits, and dust drifts like golden mist through the void. But even out here, the presence of the event horizon reaches across space like a shadow without light. It does not pull you with force. It simply bends the world around you until the only path left leads inward. And in that curve, in that gentle fall, something changes. The black hole no longer feels like a monster, but a mystery. Not a destroyer, but a guardian of secrets too deep to name. As we look toward the event horizon, we are reminded that this boundary is not a destination. It is a passage. It marks the place where everything we understand becomes something else. From the outside, we measure its shape, its size, its spin. We know it holds mass. We can calculate how it affects stars and light and time. But what it holds inside, the true nature of the core, the ultimate fate of the information it gathers, is hidden from us. And perhaps it is that hiddenness that makes it so powerful. Sometimes black holes collide. When they do, their event horizons ripple and merge, sending waves across the universe, gravitational waves. These ripples in spacetime travel for billions of years before reaching Earth, where special observatories listen with delicate instruments. When we hear them, we are not hearing sound. We are feeling the motion of space itself. We are catching the afterecho of two horizons becoming one. And in that quiet ripple, we learn a little more about how the fabric of reality stretches and bends. But not all black holes are dramatic. Most simply exist, quiet, sleeping. Their event horizons are like soft outlines, boundaries drawn not in color or light but in absence. They are everywhere, in the centers of galaxies, in the spaces where stars once burned, in corners of the cosmos we haven't yet reached. And even though we can't see past their edges, we know they matter. Without them, galaxies would drift apart. Without them, the universe would not be what it is. There is something beautiful about the event horizon's stillness. It reminds us that not everything needs to be known right away. Some answers take time. Some questions are worth waiting for. The horizon teaches patience. It teaches respect for the vast, the hidden, the unknowable. It shows us that mystery is not failure. It is a sign that we are still learning, still listening. Some scientists dream of a future where we can understand what lies inside. They imagine new tools, new theories, new ways of seeing. Maybe one day we'll know what happens to the things that fall past the horizon. Maybe we'll learn how information is stored, how space behaves at the edge of time, how the universe folds itself inward like a secret note passed between stars. But even if we never know, the event horizon still gives us something important. It gives us wonder. For children looking up at the night sky, the stars are enough. They shine, they twinkle, they tell stories. But as we grow, we begin to ask what lies between those stars. What lives in the dark? What pulls without light? And that's when we meet the black hole, not as a monster in the sky, but as a silent teacher. A reminder that the universe is more than what we see. It is also what we can't. In the end, the breathless silence beyond the event horizon is not emptiness. It is fullness beyond form, a place where all the stories fold inward, a place where the universe holds its breath and listens to itself. We cannot cross it. We cannot speak from within it, but we can stand near it and feel the tug of something ancient and deep, something that changes space, something that bends time, something that reminds us how much we still have to learn. And so we watch, we measure, we dream. The event horizon remains where it has always been, not a barrier but an invitation, not an end but a beginning, a soft line drawn by the cosmos to say, gently, there is more. Sometimes the most powerful things are not the ones we see but the ones we feel. A breeze we can't catch, a scent that floats by without a trace, And in space, there are giants that do not shine, do not roar, do not move with fury, yet their presence is undeniable. These are dormant black holes, titans asleep, invisible, unlit, and silent, but still strong enough to pull stars into careful motion, to shape galaxies without lifting a finger of light. Their gravity is ghostly, always present but rarely seen. It whispers through space, drawing the universe inward like a soft breath. To understand ghost gravity, we have to imagine motion without cause. Picture a star spinning in a wide circle, moving swiftly but without anything visible at its center. There is no glowing object pulling it in, no bright sun, no flickering core. And yet it orbits something. It curves, it speeds up, it slows down. This is how we find the hidden titans, not by their light but by the way they bend the world around them. The stars become clues. Their paths are signatures of an unseen force. In the outer arms of galaxies, stars spin faster than they should. According to visible mass, they ought to drift apart like leaves in wind. But something holds them together, something heavy, something dark. Some of this pull comes from dark matter, but often deep in the center there is another reason, a black hole, massive and quiet, resting at the heart. It may not be feeding, it may not be glowing, but it is there, holding the galaxy like a spider web holds dew, softly but with purpose. The gravity of a dormant black hole is different from what we feel on Earth. Here, gravity keeps us on the ground, holds the moon in orbit, shapes the tides. But a black hole's gravity is more than a pull. It is a curve in space itself. Imagine stretching a rubber sheet and placing a heavy ball in the center. Smaller balls roll toward it, not because the ball pulls them, but because the sheet curves. That is what gravity is around a black hole, a bend so deep that not even light can escape once it falls too far. Yet when the black hole sleeps, it does not feed on stars or gas. Its mouth is closed, its edges are still. There is no violent swirl of matter, no X-ray burst, just the gentle influence of mass. In this dormancy it becomes like a ghost, still powerful but easy to miss. Without telescopes that can track star movement, we might never know it is there. And still, even without light, it continues to shape the future of everything nearby. Some galaxies have black holes with billions of times the mass of our Sun. These supermassive giants sit quietly at the center, almost unnoticed. For now, they sleep. But their history tells a different tale. Long ago, they may have flared with energy swallowing stars whole, sending out jets of radiation thousands of light years long. But now their hunger has passed. The galaxy around them has grown calm. And so they rest, not vanished, not defeated, just waiting. These dormant black holes are not only in galaxies far away. They may be closer than we think. Scientists believe that stellar mass black holes, smaller cousins to the supermassive ones, exist throughout the Milky Way. Some may be as near as a few hundred light years from Earth, hidden among the stars. They do not shine. They do not make noise, but their ghost gravity bends space just the same. To find these hidden titans, astronomers watch for stars that move without reason. They look for binary systems, pairs of stars, where one seems to circle an invisible partner. They track how the star wobbles, how its light shifts, how its path changes over time. From this dance, they estimate the mass of the unseen object. If it is too heavy to be a star, too quiet to be a neutron star, it may be a black hole. A silent one, a sleeper, a ghost in the dark. These discoveries are rare but growing. With better tools and sharper eyes, we're beginning to map the quiet giants. We're learning that they are not rare accidents but natural parts of cosmic evolution. Most massive stars leave black holes behind when they die. Most galaxies likely carry a black hole in their heart, and many of these are sleeping, waiting, unseen. Ghost gravity teaches us something humbling. It tells us that the universe is not always loud. That power can be hidden. That motion does not need fire. The black holes that rest quietly among the stars remind us that even in stillness there can be strength. Even without light there can be influence. And even without being seen, something can shape everything around it. Let's drift deeper into the ghostly grip of gravity that never sleeps. When a black hole rests, it does not disappear. Its mass remains. Its influence spreads. And though its light is gone, its presence is etched into the way the universe moves. In many ways, this invisible influence is more haunting than the flares and bursts of active black holes. It's quiet, patient, everywhere. The very structure of the cosmos bends gently around it like wind curling around stone. Galaxies, for all their swirling light and motion, are fragile things. Without the anchor of gravity at their core, they would drift apart, unraveling into the void. The black hole, hidden and still, is the pin at the center of the wheel. It doesn't speak, but it holds. It doesn't burn, but it balances. Even asleep, it remains the reason galaxies stay whole. Scientists call these forces gravitational wells, deep valleys in the invisible landscape of space where mass collects and light falls inward. Dormant black holes are the deepest of these wells, quiet and unglowing, but vast in reach. In the early days of astronomy, the idea of a black hole seemed impossible. How could something be there and not be seen? How could an object trap light itself? And yet, as we watched stars and galaxies more closely, patterns began to appear. Stars moving too fast, light bending too much. Entire galaxies held together more tightly than their visible mass could explain. The answer was not in what we saw, but in what we felt, the ghost gravity of something unseen. Today, we use advanced instruments to trace this hidden gravity. We study the way stars wobble, the way galaxies rotate, the way gravitational waves ripple outward from distant collisions. Each signal, each motion, each curve adds a piece to the puzzle. And slowly, we are building a map of the invisible. A chart not of stars and dust, but of gravity itself, its shapes, its flows, its echoes. In this map, dormant black holes appear not as points, but as silences, as still places that pull on everything around them. This ghost gravity also affects time. Near a black hole, time passes more slowly. The deeper into its gravitational well you go, the more stretched time becomes. For a spacecraft drifting past a sleeping black hole, hours might pass like minutes. If you could hover just above the event horizon, years could pass for others while only moments pass for you. This is not a dream or a story. It is a tested truth of physics. A quiet reminder that gravity is not just a force, but a sculptor of time itself. Sometimes a sleeping black hole is awakened. A passing cloud of gas or an unlucky star may fall too close. The black hole stirs. It pulls the material inward, heating it, twisting it into a spiral of light. It flares with energy, then slowly dims again. The ghost becomes a beacon for a moment. But when the meal is gone, the light fades. The black hole returns to silence. Its gravity never left. It simply added more to its weight, deepening the curve in space, tightening its grasp. Even when black holes collide, the event is more felt than seen. The merger of two titans sends waves through the very fabric of space, gravitational waves that stretch and squeeze the universe itself. These waves travel across billions of light years and reach Earth with the force of a whisper, yet we can detect them. And in those ripples, we hear the story of sleeping giants merging, their ghost gravities combining into one deeper silence. There is beauty in this kind of power. It doesn't demand attention. It doesn't flash or roar. It simply endures. The ghost gravity of a dormant black hole is a reminder that influence does not require noise, that what we cannot see can still be real. That space is not just emptiness, but a fabric shaped by the things that rest upon it. Think of it like this. Imagine a dark pond. On the surface, you see no waves, no motion. But if you toss a small pebble near the center, ripples move outward, curved and slow. The center holds still. It does not speak. But its shape, its mass, determines the way every ripple flows. That is what a dormant black hole is, a center that shapes motion without moving. A silence that guides stars. A shadow that holds the sky in place. In a way, ghost gravity is not just about space. It is about us too. It teaches us that presence is not always loud. That meaning can live in stillness. That the most powerful parts of the universe might also be the most patient. Dormant black holes show us that you don't have to be seen to matter. You don't have to speak to leave a mark. You just have to be steady, quiet, and deep. Now let us follow the ripple paths of ghost gravity to their quietest depths. Imagine a galaxy without its center, its black hole erased. The stars would still shine, the gas would still drift, but something would feel off. Orbits would stretch. Shapes would loosen. Over time, the grand swirl would fade into disorder. Without the dormant titan holding its core, the galaxy would lose its spine. That silent center, though invisible, gives structure to the vast. It does not command with light, it anchors with gravity. Many of these hidden titans have not stirred for millions of years. They do not glow with the chaos of matter falling in. They do not roar with radio waves or emit blasts of energy. Instead, they sit in their deep curves in space, wrapped in quiet. But their influence never rests. Every star in their galaxy orbits a path curved by their pull. Every gas cloud sways in slow spirals because of their weight. Even as they slumber, they choreograph the motion of millions of suns. And perhaps what's most poetic is how their silence is not total. If a star swings too close or a drifting cloud of hydrogen falls into their reach, the black hole may flicker to life. It doesn't wake with anger, it feeds with precision. The matter circles inward, heating as it falls, lighting up as friction pushes particles to glow. The dormant giant becomes briefly visible. Then, as quickly as it came, the glow fades. The hunger is gone, and the black hole returns to its quiet. These brief awakenings teach us something deeper about their nature. Black holes are not endlessly devouring. They need fuel to flare. And in many corners of space, fuel has grown scarce. The galaxies have aged. The easy meals have drifted far. And so, many black holes have settled into long sleeps, billions of years of rest, marked only by the slow gravity that keeps the cosmos balanced. Astronomers now believe that most galaxies, including our own, contain these sleeping giants. The black hole at the center of the Milky Way, called Sagittarius A, is relatively quiet. It flares occasionally, but mostly it rests. And yet its presence shapes the entire galaxy. From stars like ours to planets like Earth, everything exists in the gentle influence of its gravity. We are part of a system held together not just by what shines, but by what rests in shadow. When two galaxies merge, a common event in the life of the universe, their black holes may eventually meet. At first, they dance around each other, spiraling closer over millions of years. Then, with a final rush, they collide. The event sends gravitational waves across the universe, shaking spacetime like a drumbeat too deep to hear. And when the shaking ends, a new black hole is born, heavier, quieter, its gravity even more profound. Some scientists believe that in the far future, when stars no longer form and light fades from the cosmos, black holes will be the last structures standing. They will drift through the dark like ancient stones in an endless sea. They will no longer flare. They will no longer feed. But their mass will remain, and their ghost gravity will continue to shape the silence. In this future vision, the universe becomes a place of slowness. No fire, no shine, just motion and memory. Black holes may evaporate over unimaginable spans of time, their mass dissolving into the faintest whisper of radiation. But even then, their history will be written in the shapes they once carved, the galaxies they held, the stars they steadied, the balance they offered when everything else flickered and changed. What does this tell us here and now? It reminds us that influence does not require sound, that stability is not always seen, that the most important forces can work quietly over time without ever needing attention. Ghost gravity is the touch that never leaves a mark, the pull that never asks to be noticed. And yet, without it, the universe would be undone. So the next time you look into the night sky and see the stars moving in their perfect rhythm, remember what's holding them there. Remember the black holes that slumber behind the light, the silent giants that shape the stage, the invisible titans whose ghost gravity keeps the music playing long after the lights have dimmed. They may not speak, they may not shine, but they remain present, patient, and profound. There comes a moment in the life of light when it meets a silence so deep, so final, that it cannot return. This is the moment when light falls toward a black hole. It stretches, slows, and reddens, whispering its last goodbye to the universe before vanishing forever. This is not an explosion or a crash. It is a drift into stillness, a soft unwinding of brightness into the darkest silence we know. These are the echoes that never escape, trapped at the edge, circling the mouth of infinity, drawn across the event horizon by a gravity so deep it becomes a kind of forgetting. To understand what happens to light near a black hole, we first have to understand what light is. Light is motion. Light is energy. Light is time stretched thin across space. It travels faster than anything else. It brings us every image we've ever seen: stars, galaxies, sunsets. But near a black hole, even light finds its limit. The path it once followed becomes warped. The rules it obeyed begin to bend. And in the deepest wells of gravity, light begins to curve, then spiral, then fall. There is a region just outside the event horizon called the photon sphere. Here, light can orbit the black hole in a perfect, endless circle, not falling in but not escaping either. A beam of light fired sideways at just the right speed will loop around the black hole endlessly, caught in a gravitational dance with no end. But this is a fragile balance. Any small nudge, any slight shift, and the light either escapes into space or falls inward forever. In this thin shell of space, the black hole captures the outlines of everything around it. It becomes a mirror made of gravity, a dark lens through which the universe sees itself distorted. When light does fall in, it does not scream. It does not resist. It simply fades. As it approaches the event horizon, it stretches. Its wavelength grows longer, its energy weaker. It turns redder and redder until it slips below the level of detection. To an outside observer, it looks like the light is taking longer and longer to reach them until eventually it just stops. The light still exists for a moment, but it is moving through space so bent, so slow, that it can never be seen again. This redshifting is more than just a fading. It is time itself slowing down. The closer light gets to the event horizon, the more time seems to pause. If a flashlight were aimed directly upward from just above a black hole's edge, its beam would climb very slowly, losing energy as it rose until it disappeared altogether. Not because it was blocked, but because it had no more strength to climb out of the curved space. Light, the fastest traveler in the cosmos, is stopped not by a wall, but by the shape of spacetime itself. Sometimes we catch echoes of these lost lights, not the light itself, but the energy released when something falls into a black hole. A gas cloud spiraling and may flare with X-rays. A star pulled apart may flash with ultraviolet light. These are the screams of material as it nears the horizon, heated and twisted before it disappears. But the final moment, the fall itself, is hidden. We cannot see it. We cannot record it. All we know is that the light has gone and it is not coming back. This silence is not sad. It is part of the rhythm of the cosmos. Stars are born, they shine, and they fade. Some of their light reaches us. Some of it travels toward black holes. And that light, even as it disappears, leaves a mark. The energy it gives off before vanishing helps us understand the black hole's behavior. The swirl, the heat, the glow, they are all part of the last goodbye. A soft, cosmic farewell written in invisible ink. Even now, scientists use massive telescopes to watch these goodbyes. They track flares, echoes, shadows. They measure how light bends and curves near the edges. One of the most famous images in astronomy is the shadow of a black hole in galaxy M87, a ring of glowing gas surrounding a dark center. That dark circle is not the black hole itself, but its silhouette, outlined by light that almost escaped but didn't. Those photons circled, danced, bent one last time, and then were lost. What we see is the memory of their struggle. In these moments, black holes are revealed not through light, but through its absence, through the curve of what was almost seen, through the shape left behind by what was almost felt. And in that outline, we discover the presence of something so dense, so strange, that even light itself cannot say goodbye without disappearing. Let us follow the fading trail of light even closer, where its final journey becomes a lesson in the way space and time themselves begin to fold. In the presence of a black hole, light behaves unlike anywhere else. Normally, light moves in straight lines, across empty space, between stars, around planets. But near a black hole, those lines bend, pulled inward by gravity so intense that even the straightest path becomes a spiral. What once flew freely now loops, arcs, and ultimately disappears into silence. In many parts of the universe, we understand light as a messenger. It carries stories from stars billions of years old. It paints our sky with colors, reveals the shapes of distant galaxies, and warms our planet. But near a black hole, that messenger becomes trapped. Its message cannot be delivered. We never see what it saw, we never learn what it carried. The story ends unfinished just beyond the horizon. The photon sphere is one of the strangest places in all of physics. It is not a surface or a wall, but a region where light becomes trapped in orbit. Imagine a beam of light looping endlessly around a black hole, not falling in, not flying away, just spinning. This delicate dance only happens at a very precise distance, and it is unstable. A tiny shift can send the light inward forever or outward back into space. But in that moment of balance, the black hole becomes a lens, wrapping the universe around itself. The light from behind the black hole can be bent so sharply that it appears in front of it. Multiple images of stars and galaxies can appear, warped and stretched, like reflections in a curved mirror. This phenomenon is called gravitational lensing. We've seen it happen not just near black holes, but anywhere gravity is strong enough to bend light. It allows us to see galaxies hidden behind other galaxies. It shows us the invisible structure of the cosmos. But near a black hole, the lensing becomes extreme. The light no longer just bends, it folds. It loops back on itself. It creates a ring of fire known as the Einstein ring, a glowing outline around the darkness. This is not light from the black hole, but light trapped by it, shaped by it, echoing around it like voices in a circular canyon. Still, not all light dances. Much of it simply falls, and as it does, it stretches, its wavelength pulled longer by the deepening gravity. This is gravitational redshift, and it's a signature of the black hole's presence. The light loses energy, not because it is slowed, but because it climbs uphill through curved space. The closer it gets to the event horizon, the more stretched it becomes, until it is no longer visible. Infrared, microwave, radio, each step lower, each wave longer, until finally it is gone. From the perspective of someone watching from afar, it seems as if the light slows, fades, and then freezes just at the edge. They never see it fall in. They never see it cross. The light appears to hover, stuck in a loop of time stretched too thin to continue. But from the light's own point of view, if light could have a view, there is no pause. It simply moves forward, crosses the horizon, and continues into the black hole's interior, where the rules of space and time dissolve. This disconnect between perspectives, between what we see and what the light experiences, is one of the most beautiful strangenesses of black holes. The universe does not have a single clock, a single perspective. Time flows differently depending on where you are, how fast you move, how deep into gravity you fall. A second near the horizon may be an hour to someone far away. And so, the final journey of light becomes two things at once, a slow goodbye and a swift descent. Even the light from the stars that fall into black holes carries secrets. As they stretch and spiral inward, they shine their last messages into the cosmos. Telescopes can sometimes catch these moments, brief flashes of light that appear and then fade. These flares are not the black hole itself, but the matter just outside it, heated by the terrible friction of being pulled apart. They tell us about the size of the black hole, the speed of its spin, the temperature of the falling gas. But they never tell us what lies beyond. That part of the story is always missing. Some scientists believe that, deep within the black hole, all the light and all the information is somehow preserved. That the universe does not truly erase anything, even if it appears to. This idea suggests that the event horizon might be a kind of storage space, a cosmic library of everything that has ever fallen in, every photon, every atom, every thought. We do not yet know how to read this library. But its presence offers hope that light's last goodbye is not the end of its story, only a new kind of silence. And so when we watch the edge of a black hole, we are not just seeing darkness. We are seeing the boundary between known and unknown. We are watching light make its final turn, its final reach toward freedom, and then let go. That moment, silent, invisible, is one of the most profound events in the universe. A photon, the smallest bit of brightness, meets its end not in destruction but in transformation. It becomes part of the black hole's shadow, part of its gravity, part of its mystery. Now let us follow that final echo of light as it fades not into nothingness, but into the quiet shape of memory carved in space. Even though we can no longer see it, even though it no longer reaches us, the light leaves something behind. A fingerprint, a curve, a silence that still holds the shape of the song it once sang. This is how the black hole tells its story, not with brightness, but with the absence of it, with a darkness so complete that it becomes a kind of mirror. Not reflecting light, but reflecting its loss. For all the light that falls in, for all the photons that spiral and vanish, the black hole does not become brighter, it becomes deeper, heavier. The energy of that light adds to the mass. The black hole grows quietly, invisibly. There is no burst, no glow, only a change in the way it bends space. What we see is not light expanding, but space curving more sharply, like a soft indentation becoming a deeper well. And around that well, the stars still move, unaware that one of their own has disappeared forever. Sometimes a black hole will flare one last time before returning to rest. When a star gets too close and is pulled apart, it becomes a stream of gas, wrapping around the black hole like a ribbon of light. As it falls inward, it glows with heat and friction. We see this glow as a final cry, a bright flare in the dark, a moment of resistance before the fall. But even this flare is short-lived. Soon, the light is gone. The black hole grows again, and the silence deepens. This process happens all across the universe, in distant galaxies, in star clusters, even perhaps in the quiet corners of our own Milky Way. Telescopes like the James Webb Space Telescope and observatories like Chandra or Hubble give us glimpses of these farewells. They show us where light is falling, where it is stretching, where it is being lost, but they never show us beyond the edge. The final step is always hidden. And yet that boundary is not just an ending, it is an origin. The edge of the black hole, the event horizon, defines the black hole itself. Without it, there is no interior, no singularity, no curve of space. The horizon gives the black hole shape. It is the stage where the last act of light is performed. Every photon that reaches the edge adds to that shape. Even in vanishing, light participates in building the very object that erases it. Some scientists think this horizon might be more active than it appears. Quantum theory suggests that fluctuations constantly occur there, tiny dances of particles and energy. These whispers might one day explain how black holes radiate heat, how they evaporate over time, how they might eventually disappear. If that's true, then the light that falls in might not be gone forever. It might be returned in another form, over eons, as a faint wash of energy across space. Not the same light, but a memory of it. Others think that the information in light is never truly lost, that it is encoded somehow on the surface of the black hole, that every falling photon writes a line in an invisible script. This idea, still debated, means that black holes are not erasers but archives, that they hold every beam of light, every drop of matter, every moment that passed their threshold, not destroyed but preserved in a way we do not yet understand. Even if we never read this script, the possibility changes how we see black holes. They are not the end. They are a part of the universe's deep memory, silent, dark, and unreachable, but still participants in the great unfolding of space and time. They are the places where light rests, where it is gathered, pressed inward, woven into gravity itself. And maybe in this silence there is a kind of peace. Light travels far. It stretches across billions of miles. It bounces from planets, shines through atmospheres, carries warmth and vision. But eventually, even light gets tired. Even it must stop. And when it does, the black hole offers it a resting place, a final horizon, a final goodbye. So the next time you see a beam of sunlight or the shimmer of a star, remember that not all light escapes. Some of it travels to places we can't follow. Some of it bends, slows, stretches, and disappears. And in that disappearance, it becomes part of something vast, something quiet, something so dense it shapes the motion of galaxies. That light does not vanish. It becomes the gravity that holds the stars. It becomes the shadow that tells us where the silence lives. It becomes the echo that never escapes, but is never truly gone. Time does not tick the same everywhere. It stretches and softens near great masses. It slows in the deep grip of gravity. And near a black hole, time becomes something else entirely. It no longer moves with steady steps. It begins to fold, to drag, to hesitate. This is one of the strangest and most beautiful truths of the universe. Time can collapse. And inside a sleeping black hole, where even light cannot escape, time becomes a whisper, barely moving, barely breathing, stretched so thin it feels almost frozen. Imagine standing far from a black hole. Your watch ticks normally. A second passes, then another. But as you drift closer, something changes. At first, it's almost too small to notice. Time begins to slow, not for you, but for those watching you from a distance. Their clocks still tick, but yours seems slower. Your movements appear delayed. Your voice sounds stretched. As you approach the event horizon, this delay grows deeper. To someone watching from far away, you seem to pause at the edge. You never fall in. You never vanish. You simply freeze, caught in a single frame of time. But from your point of view, you continue to move. You cross the horizon. You fall inward. Time for you flows as it always has. But you are now inside a place where time and space trade places, where forward in time becomes forward in space, where every path leads inward. This strange shift is not imagination, it's the prediction of general relativity. And while we cannot visit the interior of a black hole, the math tells us a clear story. Time slows the closer you get. And inside, it may stop altogether. A sleeping black hole doesn't make noise. It doesn't glow. But its gravity is still enormous. Even when it is not feeding, not flaring, not active, its mass continues to pull on the world around it. And this pull doesn't just bend space, it bends time. Every star that orbits it moves through a slightly slower clock. Every photon that climbs out of its gravity loses a little bit of its energy. Even far away, the sleeping giant changes the pace of the universe. At the heart of the black hole is something we cannot see, a singularity, a point where all the mass is crushed into something beyond our comprehension. Here, the equations break down. Time may not exist at all, or it may be compressed into something infinitely small. We do not know. We cannot know. The event horizon cuts us off from this place, not with walls, but with silence. Once time collapses beyond that line, it collapses in ways we cannot measure. This collapse is not violent, it is not loud. It is a soft undoing, a folding in, a slowing down so complete it becomes stillness. And yet this stillness is filled with gravity. It shapes the stars, the gas, the galaxies. The black hole's interior may be unreachable, but its effects ripple outward across space. We see it in the way stars move, the way light bends, the way time shifts. If you place two clocks, one on Earth, one near a black hole, they would drift apart, not physically but in what they measure. After some time, the clock near the black hole would fall behind, not because it's broken but because time itself is passing more slowly there. This isn't theory, it's fact. We have measured it. Time moves slower in stronger gravity. Black holes simply take this truth to its deepest level. Even a dormant black hole, resting quietly in the heart of a galaxy, causes time to drag in its shadow. Around it, stars spin in slow curves. Dust swirls in spirals stretched wide. And just outside the event horizon, time moves so slowly that an outside observer would never see anything fall in. The black hole becomes a vault of moments that never seem to finish. A museum of time where every second is stretched thin across the curve of space. This concept of time being pulled, bent, slowed, challenges the way we understand motion, memory, and meaning. We are used to time being steady, predictable. But the universe is not built on steady things. It is built on curves and changes, on gravity and light. And in the black hole's presence, time becomes part of that dance. So when we speak of sleeping black holes, we must remember they are not only still in space, they are still in time. Their rest is not just a pause, but a slowing of the clock itself, a retreat from the pace of the universe, a deep, gravitational breath that never fully exhales. Let us step more gently into this idea, that time, so familiar and constant in our lives, becomes soft and strange near a sleeping black hole. This softening isn't poetic exaggeration, it's real. Gravity slows time. The stronger the gravity, the slower the clock. And a black hole, even when quiet, holds gravity like a clenched fist. Near it, the seconds stretch. Minutes wander. Hours become long shadows. And the closer one gets, the more time begins to surrender. To understand how this works, imagine two astronauts. One remains far from the black hole, safely orbiting at a distance. The other drifts closer, just outside the event horizon. Both carry identical clocks, ticking in unison at the start. But soon the clock near the black hole ticks more slowly. The astronaut sees the world normally, but to the one watching from afar, she moves as if underwater. Her voice, her breath, her gestures, slower, deeper, drawn out like a lullaby in molasses. To the distant observer, she is falling into time's thickest silence. This difference is not science fiction, it's built into the geometry of the universe. Time is not separate from space, it is part of space. And when space bends, time does too. A massive object curves the space around it. A black hole curves it so much that time begins to fray. The curve becomes so steep that all paths point inward, even time's path. This has consequences beyond imagination. If you could somehow hover at the edge of a black hole for just a few hours when you return to a safer distance, you might find that years had passed outside. Your experience would feel normal. You would not feel time slowing inside you, but the universe outside would have marched far ahead. The stars would have shifted. The planets would have moved. The people you knew might have grown old. Time's collapse inside the black hole is not just an idea, it is a wall between two worlds. And yet this wall has no sound, no color, no flashing lights. The event horizon is perfectly smooth. You would not feel it as you pass through, you would not notice the moment, but outside your passage would be invisible, your clock would appear frozen, your light would fade and stretch. It would be the most quiet vanishing ever witnessed, not gone in a burst, but erased slowly by time's own hands. Even the signals sent from near a black hole tell this story. Light, as it climbs out of gravity's well, loses energy. Its frequency drops, its color reddens. This gravitational redshift marks the slowness of time. If a spacecraft beamed a steady pulse of light as it approached the horizon, the pulses would arrive farther and farther apart. Eventually, the light would dim beyond detection, not because it stopped, but because time, from our view, stretched it until it slipped from our grasp. And inside the black hole, the story turns uncertain. Time's path leads only inward. There is no later that takes you back, no tomorrow where you emerge again. Some theories say all matter, all time, all memory is crushed into the singularity, a point smaller than an atom where physics no longer speaks. Others wonder if something stranger happens. Perhaps the inside of a black hole is not an end, but a bridge. A tunnel to another time, another place, another branch of space. We do not know. We may never know, but even that unknowing is a kind of beauty. What we do know is this: the collapse of time begins before the fall. It starts in the slowing of clocks, the bending of light, the warping of motion. We can measure it from afar. We can test it with satellites near Earth. Even here, gravity makes time pass more slowly on the ground than on mountaintops. The black hole just deepens this truth. It takes the gentle slope of Earth's gravity and turns it into a steep, endless descent. Dormant black holes, though silent, create these slopes. Their gravitational fields shape the tempo of everything nearby. The stars closest to them move faster. The light near them curves more sharply. The clocks near them tick more slowly. Even though the black hole does nothing but exist, its existence sculpts the flow of time around it like a river carves the land. And so in the universe of black holes, time is not a constant drumbeat. It is a melody, slow and low near sleeping giants, faster and freer in open space. It changes shape. It responds to gravity. And it reminds us that the most important things often happen without noise. Time's collapse inside a black hole does not thunder. It whispers. It leans inward. It rests. We may never enter a black hole, but in our equations, in our observations, in the soft dimming of light and the steady drift of stars, we feel its pull. We feel time itself becoming quiet near its edge, not stopping, not ending, but changing, becoming soft, becoming deep, becoming slow enough to remind us how fragile and precious our brief seconds really are. Now drift with me to the very edge, the place where time is stretched into a thread so thin it can barely hold the weight of a second. This is where the sleeping black hole waits, its presence silent, its effect profound. From far away, the stars still shimmer, galaxies swirl, and clocks tick their steady rhythm. But here, near the event horizon, those rhythms grow faint. Time loosens. Space curves inward. And every motion, every heartbeat, every thought slows into something long and quiet. If you could float here, just above the horizon of a dormant black hole, you would not feel pain or pressure. You would not be crushed, but the world around you would shift. The sky would seem frozen. The stars would stop twinkling. Everything you once knew would appear paused, like a picture held in place, not because they had stopped, but because you had entered a new relationship with time. Your seconds stretch while the universe races ahead. A few hours here might equal centuries outside. This is the experience of gravitational time dilation taken to its most extreme. Inside the black hole, the future is a direction you cannot escape. There is no path backward, no exit, no return. Time no longer leads to choices. It leads inward always. Like a leaf caught in a whirlpool, there is no resting place, only descent. But the black hole does not pull with force. It pulls with curvature. The space around you becomes steep, like standing on the inside wall of a funnel. And once you begin to fall, you fall through time itself. The singularity at the heart of a black hole is not a point we can describe. It is where all known physics ends. Mass becomes infinite. Density becomes infinite. Time, if it still exists, is crushed into a moment so brief and small it no longer fits into our understanding. Some scientists believe that something else lies there, not a collapse but a seed, a doorway, a rebirth. But we do not know, we may never see it. The rules of our universe stop speaking just before we reach that final page. Still, the black hole gives us a gift. Though we cannot enter, we can feel its outline. We can study how it curves the motion of stars. We can measure how it delays the ticking of light. We can hear the songs it sends when it merges with another black hole, gravitational waves, rippling through space like soft, slow thunder. These are the signs left behind by a sleeping giant whose body is made not of matter, but of space and time folded into itself. Black holes challenge more than physics. They challenge our sense of permanence. In daily life, time feels steady. It is the beat behind every sunrise and sunset. But black holes teach us that time is a shape, that it can bend and shift, that it can be stretched and collapsed. And they show us that even something as quiet as rest can change the rhythm of the stars. In the future, when stars burn out and galaxies fade, the universe will grow quiet. There will be fewer lights, fewer flares, but the black holes will remain. They will outlive everything. Their time, already slowed, will become even slower. They will be the last archivists of a universe that once danced in light. And then, perhaps after unimaginable ages, even they will evaporate, dissolving into whispers of radiation, their final seconds stretched across the fabric of what remains. But even in their end, they will carry the memory of time's strange behavior, of seconds that slowed near their edge, of light that bent and stretched to its limits, of stories that paused, suspended at the border of forever. This is what sleeping giants offer, not fire, not motion, but gravity's deep hush, a reminder that time is more flexible than we thought, more mysterious, more fragile. So the next time you look at a clock or feel a moment pass, remember, near the heart of every galaxy, time is moving differently. Somewhere out there, a black hole is dreaming, and in its dream, time has curled into itself like a sleeping cat, slow, quiet, almost still, not gone but waiting. And through that waiting, the universe is shaped not by motion, but by the softness of time itself, folded in the arms of a giant that never truly wakes. In the quiet corners of the universe, far from the brilliant swirl of active galaxies, there are places where the light has dimmed. These galaxies are not empty, but they move slowly, like breaths held too long. Their stars drift without direction. Their cores lie still. These are galaxies without a pulse, cosmic cities whose centers no longer glow, whose hearts are sleeping black holes that have stopped feeding. Around them, dust hangs like old memories, and space stretches wide and silent, like a road with no end and no travelers. A galaxy without a pulse is not dead. It still exists, still turns, still shines faintly with the faded light of old stars. But it has lost something, its fire, its rhythm, its heartbeat. In younger, more active galaxies, black holes at the center stir and shine. They feed on gas and dust, forming blazing disks of hot matter. They send jets of energy streaming across space, shaping the galaxy's structure with powerful outflows. But in these silent galaxies, the central black hole has gone quiet. The fuel is gone. The feast has ended. What remains is a massive object, heavier than millions or billions of suns, resting in perfect stillness. These galaxies are often called elliptical galaxies or red and dead galaxies, named for their old, red stars and their lack of new star formation. The dust that once gave birth to stars has been swept away or burned off long ago. Without cold gas clouds to collapse, no new stars are born. And without fresh matter to fall inward, the central black hole has nothing left to consume. The balance that once powered a glowing core has faded. What's left is gravity and dust, drifting in long spirals with no fire at their center. Imagine walking through such a galaxy. The stars around you are old, faint red giants and fatting white dwarfs. The sky above would be dimmer, dotted with ancient light. There would be no brilliant bursts of supernovae, no glowing nebulae where new stars ignite. The silence would be more than sound. It would be the absence of change, the absence of growth, a stillness that stretches across tens of thousands of light years. And yet even here, the sleeping black hole is not powerless. Its ghost gravity still holds the galaxy together. It keeps the stars from drifting away. It bends the paths of light. It marks the center with a silence so dense, space itself curves around it. The black hole does not need to feed to remain important. Its mass alone is enough to shape the world around it. It is the unseen spine of a galaxy that no longer dances but still stands. Astronomers study these galaxies to understand how the universe ages. They look at the light from their stars, the temperature of their dust, the motion of their orbits. They find clues that speak of a more active past, evidence of flares, of collisions, of times when the galaxy pulsed with energy. But those days are gone now. The black hole sleeps. The gas is gone. The roads of dust remain but no longer lead to anywhere new. Sometimes a galaxy without a pulse may briefly awaken. If another galaxy passes too close or merges with it, new gas may be thrown toward the center. The black hole stirs, it flares, it feeds. For a time the galaxy glows again, but often the fuel is not enough. The awakening is short. The light fades. The silence returns. This cycle, bright youth, quiet middle, silent old age, is written across the cosmos. It mirrors the lives of stars, of planets, of people. We are born, we grow, we shine. Then we rest. Then we wait. In galaxies without a pulse, the universe shows us that rest is not failure. It is part of the pattern, part of the story. The dust roads that wind through these galaxies are not empty paths. They are the remains of movement, of life, of energy that once flowed toward the center. They are fossils of fire caught in slow motion, drifting without a goal. And yet, even without purpose, they are beautiful. They reflect light. They trace curves. They remind us that even in silence, structure endures. In this way, galaxies without a pulse are not forgotten. They are not lost. They are the elders of the universe, quiet, slow, and full of memory. Their black holes may sleep, but their gravity still speaks. Their stars may fade, but their shape still holds. And their dust, drifting down roads that no longer lead to birth, still glows softly with the light of everything that came before. Let us now journey deeper into the quiet heart of these galaxies where nothing new has stirred in a long time. The dust still floats through the dark, but it no longer gathers. The gas no longer cools into stars. The black hole no longer feeds. In this stillness, time itself feels stretched, not in the gravitational sense, but in the way silence stretches a room after the music ends. These galaxies exist in that long moment of pause, the one that comes after the last note but before the memory fades. Most galaxies begin their lives full of motion, stars bursting into being, gas clouds collapsing under their own weight, supernovae flinging heavy elements into space. In the center, a black hole grows by drawing in what surrounds it, sometimes slowly, sometimes with sudden, hungry flare-ups. These active galaxies blaze in X-rays and gamma rays. They shine with the heat of creation. But this cannot last forever. Over billions of years, the galaxy's energy fades. The black hole grows full. The material that fed it becomes scarce. And when the meals stop coming, the giant closes its mouth and rests. The transformation from an active to a passive galaxy is not sudden. It is a slow dimming, a gentle falling away of energy. The central black hole may have once spun rapidly, dragging space itself along with it, lighting up the surroundings with jets that span light years. But now it spins in silence, still massive, still dense, still present, but no longer blazing. Around it, the stars have aged, most of them small, red, and long-lived. The massive, short-lived stars have already lived their lives, ending in bursts that shook the galaxy's core before fatting into neutron stars or black holes of their own. These galaxies, sometimes called quenched, have lost the raw ingredients for growth. The cold molecular gas needed to form new stars has either been consumed or heated until it can no longer collapse, and without fresh stars, the galaxy turns inward. It becomes defined not by its future, but by its past. The starlight we see is the starlight of history. The dust that swirls is no longer building but remembering. It traces the paths that once fed the center, the old roads of creation now wandering through silence. The sleeping black hole at the center continues to shape everything. Though unseen, its gravity is written into the motion of stars, the swirl of dust, the tilt of galactic arms. Some of these black holes weigh more than 1 billion suns. Yet their influence is gentle, not in force but in the quiet control of orbits, like a conductor who has stopped moving but whose orchestra still follows the final note. The black hole does nothing, yet the galaxy still listens. Astronomers have developed sensitive instruments to study these quiet giants. They look for infrared signals from old stars. They track the slow drift of stellar populations. They search for evidence that the black hole has flared in the past, signatures of energy left behind in the patterns of gas. Sometimes, they find bubbles of emptiness in the galaxy's core, places where the black hole once expelled gas so powerfully that it cleared entire regions. These are the echoes of activity, fossilized into structure. But most often what they find is stillness, light that does not flicker, paths that do not change, energy that does not build. And yet in this stillness there is elegance. The galaxy has entered a new phase not of creation but of preservation. It is not empty, it is settled, not broken but resting. It carries the memory of everything it once was, and it carries that memory gracefully. Some wonder whether these sleeping black holes will ever wake again. Could a wayward cloud of gas pass close enough to reignite the center? Could a small satellite galaxy bring fresh material? These things are possible, and in some rare cases we've seen it happen. But in most cases the black hole remains still. Its hunger has gone quiet. The galaxy around it does not offer enough to stir it. And so, they wait together, old companions in a universe that is slowly running out of light. These galaxies remind us that not every silence is emptiness. Not every stillness is death. There is meaning in the quiet, in the form that remains, in the memory that endures. The dust roads, though they lead nowhere new, still reflect the starlight. They still curve through space with grace. They still tell a story, not of what will be, but of what once was, and how beautifully it all came together before growing still. Let us drift one last time through the soft hollows of these quiet galaxies, where motion remains but purpose has faded. The stars still orbit slowly, like dancers long after the music has stopped. The dust still swirls in loops carved long ago by gravity's hand. But there is no spark, no fresh heat, no newborn light. These are places where the cosmos has exhaled and not breathed in again. And at the center of it all, unmoving, unseen, unshaken, rests the black hole, sleeping in perfect stillness. This stillness is not just physical. It is a pause in story, a resting place in time, a moment stretched across billions of years where very little changes, yet everything is held together. The dust roads that once carried gas and light to the heart of the galaxy are now quiet lanes of memory. They curve through the stars like old trails no longer used but never erased. They hold the shape of what once mattered. They whisper of movement, though they no longer move with purpose. In these galaxies, the black hole's hunger has been replaced by patience. It no longer feeds, but it does not disappear. It waits. Its presence is felt in the arcs of stars and the deep wells of gravity. Every orbit remembers it. Every beam of light that passes too close bends slightly in acknowledgement. And though it no longer flares, its influence still defines the galaxy's form. Not through force, but through the memory of what it once was. We may think of these galaxies as faded, but they are not forgotten. They are archives, not in books or data, but in curves and silences. The stars within them contain the heavy elements forged in ancient supernovae. The dust carries the carbon and oxygen that once built planets and possibly life. These galaxies may no longer create, but they contain the tools, the stories, the blueprints of everything that came before. And in their centers, the black holes hold not only mass but mystery. Though they sleep, they are not done. They are reminders that even in silence, something enormous can remain. That gravity, once awakened, never truly lets go. These black holes are monuments, vast and invisible, to the fire that once fed them and the dust that still drifts in their wake. Perhaps one day, when galaxies collide or gas falls inward once again, some of these black holes will stir. They will flare for a brief moment, relighting the hearts of their homes, but most will not. Most will remain quiet, their time of activity lost in the long tide of the universe's aging. And that is not a tragedy. That is simply the way of things. Just as stars burn and fade, so too do galaxies breathe and rest. Astronomers continue to look into these quiet realms, not to find what is new, but to understand what has lasted. They measure the light of old stars. They trace the edges of gas. They build maps of what remains, and in doing so, they uncover a kind of cosmic wisdom, one that doesn't burn hot or shout loud but waits and watches and remembers. These galaxies teach us that longevity is not about noise, but balance. That beauty does not always require birth. That sometimes, the most meaningful stories are written in dust. And when we look up from our small place in the cosmos, we can know that these dust roads stretch far beyond what we see. They spiral through time and memory, through stars that are older than Earth, through black holes that have been silent since before our sun was born. They are not roads to somewhere. They are roads through something, through what was, and still is, in the slow, graceful quiet of a galaxy at rest. So if ever the night sky feels too still, remember, there are galaxies out there without a pulse but not without a presence. Their light may be dim, but their form still holds. Their hearts may be quiet, but their gravity remains. And their dust roads, though they lead nowhere new, are beautiful for having led somewhere once. Some things in the universe are known not by their presence but by their absence, not by what they show but by what they hide. Black holes are among them. They do not glow, they do not reflect, they do not speak in light. And yet they are there, massive, heavy, central to the shape of galaxies. To find them, we do not look for brightness. We look for movement, for curves, for silence that bends the stars. This is how we map the invisible weight of black holes, not by what we see, but by how everything else responds. Imagine watching a star spin around empty space. There's no light, no object at the center. Yet the star moves as if it's caught in orbit. Its path is curved, steady, pulled. Something is holding it, something massive, something dark. This is the fingerprint of a black hole, an unseen presence written into the motion of what surrounds it. Astronomers call this gravitational influence. The black hole doesn't have to touch the star. Its weight bends space itself, and the star follows that curve like a dancer following invisible lines on a floor. The first black holes were discovered this way, not through images but through indirect signs. A star's wobble, gas that heats as it spirals into nothing, X-rays flickering from empty regions. Again and again the story was the same, motion without a visible mover. Over time the evidence grew. The Milky Way's center, once thought empty, revealed stars dancing in tiny, tight orbits around a silent mass. It had no light, but it had weight, and that weight told us, a black hole lives here. This way of seeing is gentle. It doesn't rush. It watches carefully. It notices the delay in a signal, the slight shift in a path, the redshift of light pulled against gravity's hand. It listens to what isn't there. And in that quiet, a picture begins to form, not a photograph, but a map of influence, a drawing of space that curves even where our eyes see nothing. The weight of a black hole can be measured by how fast stars orbit near it. The tighter the orbit, the stronger the pull. And the stronger the pull, the heavier the object must be. From this, scientists estimate the mass of black holes, millions or billions of times the mass of our sun, squeezed into a space smaller than the solar system. We cannot see the black hole, but we see its shape reflected in the motion it creates. In some galaxies, this influence is subtle. A small wobble here, a drift there. In others, it is powerful, jets of gas blasting from the center, glowing with the heat of material being torn apart. These active black holes are easier to find, but the sleeping ones, the quiet ones, require more patience. They are found by watching, waiting, tracing the patterns of things that should not move the way they do, unless something invisible is pulling on them. Even light, the universe's fastest traveler, bends near a black hole. It curves around the edge, changing direction not because it wants to, but because space itself is curved. This bending, gravitational lensing, can stretch and multiply images of distant stars, showing us how the black hole shapes the space around it. In this way, the black hole becomes a lens, not made of glass but of gravity. A lens that doesn't magnify light but distorts it, and through that distortion we glimpse its outline. The Event Horizon Telescope gave us the first real image of a black hole's shadow. Not the black hole itself, but the silhouette created by the glowing ring of gas around it. That image, blurry and golden, was the product of years of watching, of collecting signals from across the Earth, of mapping the motion of photons trapped at the edge of gravity's well. It was a picture of the shape of silence, the place where light ends and gravity begins. And even in smaller black holes, the story is the same. We find them by how they move others. A black hole in a binary system may tug its partner star, making it dance in small, strange circles. It may steal material from that star, heating it as it falls. This heat glows in X-rays, revealing the location of something that otherwise cannot be seen. Again and again, the black hole leaves no mark of its own, but everything around it bears its trace. In this way, the invisible becomes visible, not through light but through motion, not through color but through curve. The shape of silence becomes something we can know, not by touching but by listening, by noticing, by mapping how stars shift, how dust drifts, how time itself slows in the presence of something vast and unseen. The universe is full of such quiet shapes, not empty but full of gravity, not glowing but heavy. They shape not only the galaxies but the way we think. They remind us that not all knowledge begins in sight. Some begins in stillness, in patience, in the long, careful mapping of what silence looks like when it bends the stars. To truly understand how we map what cannot be seen, we must follow the science deeper, into the tools, the time, and the careful questions that let us trace shadows without ever glimpsing the object that casts them. We start not with sight, but with gravity, with the pull of one star on another, with the curve of light as it slips past an invisible mass, with the way space itself bends ever so slightly when something heavy rests in it. These bends, measured in shifts, delays, and echoes, become the sketches from which we draw the shape of a black hole. One of the most elegant ways we detect black holes is by measuring the motion of stars near them. In the center of the Milky Way, astronomers have tracked a small group of stars for decades. These stars loop and spin in tight orbits, completing a full circle in just a few years. Their speeds are enormous. Their paths are precise. And yet, at the very center of their dance, there is nothing. No star, no cluster, no visible source of the pull. The only possible explanation is a black hole, 1 million of times more massive than the Sun, hidden in the dark. This method is called stellar dynamics. It relies on watching how stars move and using their orbits to calculate the mass at the center, The more tightly they circle, the heavier the object must be. These calculations are exact and patient. They do not rush. The stars speak slowly, with every orbit giving us one more line in the invisible portrait. And from these lines, we find the shape of something we can never touch. Another method is to study the way gas behaves near a suspected black hole. Gas clouds are easily moved by gravity. When they spiral inward, they heat up and glow. This glowing gas forms what is known as an accretion disk, a bright, thin ring that encircles the black hole's edge. The inner part of the disk spins faster than the outer part, and this speed reveals the strength of gravity. By measuring how fast the gas spins, we can estimate how heavy the black hole must be. These disks, too, are maps, not made of paper or ink but of heat and light. They outline the place where space curves so steeply that light itself can no longer escape, and sometimes they flare. A star gets too close, is torn apart, and its remnants blaze in X-rays as they fall. These flares are temporary, but they tell us something lasting. A black hole lives here. A hidden weight has pulled this material in, and in its final moments, the light reveals the depth of that pull. Even more subtle is the effect of gravitational lensing, the bending of light from distant objects as it passes near a massive one. When light from a faraway star or galaxy travels past a black hole, it bends. Sometimes, it bends so much that we see multiple images of the same object, or a ring of light around the black hole's silhouette. These distortions are delicate, but measurable. They allow astronomers to estimate the mass and location of black holes billions of light years away. One of the most exciting developments in recent years has been the detection of gravitational waves. These are ripples in spacetime itself, created when two black holes collide. Unlike light or particles, gravitational waves carry information directly about the motion and mass of the objects that created them. When they reach Earth, they stretch and squeeze space by the width of a proton, an impossibly small shift that we can now measure. Through these waves, we've heard black holes merge. We've listened to their final spiral, their fusion into a single, larger black hole. These signals last only seconds, but they contain volumes. They tell us the mass of each black hole, the spin, the energy released. They are a new kind of map, not of space, but of time. A chart of how two silent giants moved toward each other and became one. Each of these techniques, stellar dynamics, gas disk analysis, gravitational lensing, and wave detection, is part of a growing language for studying the invisible. Together, they form a network of observations that wrap around the black hole, outlining its presence without ever touching it. They confirm again and again that black holes are real, that they are common, and that they are among the most influential objects in the universe. Yet for all this, we have never seen a black hole directly. We have never crossed the event horizon. We do not know what lies inside. The maps we create are outlines, borders, edges of understanding. They are as much about what we cannot know as what we do. And in that, there is a kind of humility, a reminder that the universe is wider than our sight, deeper than our theories. Still, we continue to map, because even silence leaves a trail, even darkness has a shape, and by following the curves of stars, the flares of gas, the bends of light, and the whispers of gravity, we find the quiet giants that move the galaxies, not by roaring, not by shining, but by being too heavy to ignore, too central to miss, too silent not to listen to. As we come to the final stretch of this quiet exploration, we realize something deeper, that mapping black holes is not only about tracing curves or measuring light. It is about understanding the presence of what is unseen and respecting the power of what is silent. Black holes are not monsters in the dark. They are architects of motion. Though they do not shine, they shape the light around them. Though they do not speak, they organize the orbits of stars. Though they cannot be touched, they touch everything that passes near. To map a black hole is to chart the limits of our vision. It is to mark the border between what we know and what remains a mystery. Every technique we use, tracking stellar motion, measuring radiation from heated gas, analyzing gravitational waves, is an attempt to read a signature left by something we cannot directly observe. And through these efforts, we have built maps more accurate than photographs, because they reveal not surface but structure, not color but consequence. Not visibility, but presence. Consider the black hole at the center of our own galaxy. It has never been seen directly, and yet its mass is known with extraordinary precision. We know it exists because stars near it move in tight ellipses, completing full orbits in mere years, something they could not do unless held in the grip of something incredibly heavy and small. These stars, with their delicate paths, are like ink on the page of space. Their movements sketch out the hole at the center, as surely as a shadow outlines what blocks the light. But it's not just the centers of galaxies that speak of black holes. In distant reaches of the cosmos, there are gravitational lenses, massive invisible objects bending the light from galaxies behind them. When we study the distorted images, we're not looking at the black hole itself, but at what it has done to space. And from that distortion, we infer its weight, its size, its place. Again, the map appears not from the thing itself, but from the effect it leaves in its wake. Even in silence, black holes are constantly shaping their surroundings. Dust moves differently around them. Time itself ticks more slowly near them. In the curved space near a black hole, even light is hesitant, its path bending, its color stretching, its journey elongated. This hesitation becomes part of our map too. The delay of a signal, the redshift of a photon, the flattening of orbits, these are the contours of the silent presence. One day we may discover even more ways to detect and map black holes. Instruments will grow sharper. Gravitational wave detectors will become more sensitive. Our maps will become finer, not only of where black holes are, but of how they grow, how they spin, how they connect to the early universe. We will begin to see not just the mass they contain, but the histories they preserve. Each black hole may become a kind of archive, not in the way libraries store books, but in the way rivers store the memory of mountains. But perhaps the most important map of all is the one black holes draw in us. They reshape how we think about space, time, and causality. They remind us that not everything real is visible, not everything powerful is loud. They invite us to look for patterns where nothing seems to be, to believe in the truth of the unseen, to listen not just for what shouts, but for what holds everything else in place. In a way, black holes are the punctuation marks of the cosmos, the deep pauses, the silent centers, the stops that give the sentence its structure. They are the quiet that makes the music meaningful, and mapping them is an act of both science and reverence, of measuring not just what is, but what is moved, of feeling the weight of something that has no face, no voice, no outline, only consequence. So when we look into the night sky and wonder what lies beyond the stars, let us remember the black holes that hold those stars in orbit. Let us remember that silence has a shape, that gravity has a voice, that presence can exist without visibility, and let us continue to map these silent giants, not only with telescopes and math, but with wonder, patience, and respect. Because the shape of silence is not emptiness, it is everything that moves around what rests. It is the shadow that guides the dancer, the center that gives the spiral meaning, the invisible weight that shapes the stars and teaches us that even in stillness, the universe speaks. There are forces in the universe that move things, and there are forces that hold things still. Between every beat of light and burst of creation, there is something quieter, something slower, something that binds time together like stitches in fabric. Black holes, especially those that sleep, belong to this second kind of force. They do not flash across the sky or shout their presence into space. Instead, they hold time itself in place, not with hands but with weight. Not by moving, but by shaping the space through which time must flow. Every black hole is a lesson in gravity, and gravity is not just about pulling objects closer. It is about bending the stage on which time performs. Near a black hole, space curves inward like a blanket pulled tight around an unseen center, and time, normally steady and even slows, it becomes thicker, denser. Each moment takes longer to pass, and when a black hole is dormant, when it is not feeding or flaring, this bending becomes clean and silent. No distraction, no chaos. Only the slow, invisible holding of everything around it. Imagine a galaxy as a clock, spinning its stars like the hands of time. At its center is a black hole, not ticking, not moving, not counting, but anchoring. It does not shine, it does not beat, but without it the stars would drift apart, pulled by their own directions. The center would loosen, the shape would dissolve. It is the weight of the black hole that gives the galaxy its rhythm. Its stillness defines the pace. Even in sleep, it provides the anchor point against which all motion makes sense. This influence on time is not something we imagine. It is something we can measure. Satellites above Earth experience time slightly faster than clocks on the ground because they are farther from our planet's gravity. Multiply that difference by millions and place it near a black hole, and the effect becomes dramatic. A person near a black hole's edge would experience hours while years passed far away. And the dormant black hole, doing nothing but resting in the center of its galaxy, is the reason for this. But the black hole does more than slow time, it shapes its meaning. Without a central force, motion has no pattern. A star without a pull to orbit becomes a wanderer. A planet without gravity becomes a traveler with no destination. Time feels the same way. In the absence of something to bend it, it is flat, endless, undirected. The black hole folds time just enough to give it curve, pace, and presence. It makes time noticeable by pressing down on it gently. Dormant black holes are especially elegant in this role. They are pure mass, uncluttered by activity. They are like silent stones at the bottom of deep wells. They do not swirl gas or erupt with jets. They rest. And in that rest, they shape the paths of everything nearby. Time slows because gravity holds it back. Space curves because gravity pulls it inward. And the universe continues quietly around them. We often think of time as a river flowing forward without pause. But in the presence of a black hole, it is more like syrup, thick and slow. A minute stretches, an hour drips. For those far away, time runs like usual. For those near the sleeping giant, time becomes more deliberate. This difference is not illusion, it is real. It means that two people, separated only by gravity, will age at different speeds. Not because one moved, but because time itself moved differently around them. This truth becomes clearer when we study stars near the centers of galaxies. Their orbits are not just loops in space, they are loops in time. They complete revolutions faster or slower depending on how deeply they sit in the black hole's gravity well. Their very rhythm becomes a clock that tells us the weight of what lies at the center. And each of these stellar clocks is ticking under the gentle pressure of time stretched by gravity. In this way, dormant black holes help hold time together across the galaxy. They give structure to motion. They press the seconds into shape. They bend the moments just enough to allow stars to dance in patterns that last for billions of years. They are not calendars. They are not metronomes. They are something older, anchors that give motion its meaning and pause its place. And though we may never touch them, never cross their horizon, we are always feeling their influence. The shape of time on Earth, its reliability, its forward flow, rests gently on the background of these deeper curves. Far away in the still hearts of galaxies, the dormant black holes wait, not as watchers but as keepers, not as creators but as holders. Their gravity is not just weight, it is continuity. Their silence is not just absence, it is the frame through which every moment passes. Let's move closer to the quiet force that sleeping black holes exert, not on matter this time, but on time itself. When we think of time slowing down near a black hole, it's not just a poetic idea, it's a proven reality. This slow time isn't something you feel directly. You still breathe, blink, and think the same. But the rest of the universe from far away begins to speed up around you. Seconds stretch, movements slow, and all of this happens because of gravity. Dormant black holes are not dramatic. They don't spit light or pull stars apart. They simply sit holding space together. Around them, time bends in calm, slow arcs. Clocks tick gently. Stars move carefully, caught in wide loops that take hundreds or thousands of years. In this stillness, everything continues, balanced and bound by invisible weight. These black holes don't command, they keep. They don't shine, they shape. Even light feels this weight. As it climbs out of a black hole's gravity, it stretches, losing energy. Its color changes. Its speed remains, but its time does not. This bending of light is part of the map of time itself. And in galaxies where black holes are dormant, we can see this map clearly, undisturbed by chaos. Everywhere they rest, black holes change the pace of things. They don't interrupt. They influence. They don't end time. They slow it just enough to make the moment feel longer, deeper, heavier, like a pause between heartbeats, like the breath you hold without realizing it, the quiet between what was and what comes next. And it is in this quiet that black holes, though unseen, become the keepers of time's most delicate balance. Now imagine time not as something we pass through, but something held in place, stretched gently between stars, anchored by unseen weight. Dormant black holes do not force this shape, they allow it. In their stillness, time is preserved, softened, made steady. Around them, galaxies age gracefully. Their stars spin slowly. Nothing rushes. Nothing collapses in haste. It's as if the black hole tells the universe, slow down, stay here, hold a little longer. We often measure our lives in days, months, or years. But in a galaxy, time is measured in orbits, grand spirals of light and silence, held by the gravity of something sleeping. The black hole may never speak, but everything moves around it, shaped by the curve of its rest. Even in their deepest quiet, these black holes do something extraordinary. They keep the rhythm. They are the still point in a galaxy's turning, the unchanging center in a world of motion. And in their quiet grip, time flows not faster, not louder, but just enough, so that everything else can move with grace. That's the gift of a sleeping giant. Not motion, not noise, just the gentle shape of time held together by the gravity between moments.